Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today. It's on simultaneous linear equations in two variables. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to solve simultaneous linear equations in two variables. And you should be able to solve word problems involving simultaneous linear equations in two variables. So let's learn more about simultaneous linear equations. Let's consider the following equations. The first one is 3x plus 1 is equal to 5. And the second one is a minus 1 is equal to 5. In the video on Introduction to Linear Equations, we saw that these equations are linear, and we learned how to solve these types of equations. We know that from here, all you need to do in order to find x in the first case or a in the second case is to group like terms and then you simplify. Now, let's look at these equations too. In the same video on Introduction to Linear Equations, we saw that this equation here, 2a plus b is equal to 8, is also a linear equation. We explained that into details. We also saw that 3x minus y is equal to 6 is also a linear equation. But you can see that there's a clear difference between these types of linear equations and these ones. In the first instance here, you can see that there is only one variable in the equation. So in the first case, there is only x. When you look at this equation too, there is only a. But if you consider these equations here, in the first example, there are a and b in the equation. We have two variables. In the second example, there are x and y in the equation. We have two variables. So while you can just group like terms and find x or a in this case, that will be different for this because there are two variables in here. Now, when there are two variables, you are going to need two equations to solve for the variables. So you can see that from here, there is only one variable. So you need just one equation to solve. In the same way, when you come here, there's only one variable. So you need just one equation to solve it. But when you consider this, there are two variables, a and b. So in order to find a and b, you are going to need two equations. So you will need another equation to solve this. So for example, if you have 2a plus b is equal to 8, you will need another equation like a plus b is equal to negative 3 in order to find a and b. In the same way, in this example too, you will need another equation in order to find x and y. So let's say the other equation is minus 2x plus y is equal to 10. Now, we have two variables. We have two equations, so we can solve them. Here too, we have two variables. We have two equations, so you can solve them. Now, if you have two equations like this, you are going to solve the two equations simultaneously. Simultaneous is an English word and it means things that are happening together or at the same time. The two things are happening together or at the same time. Because we have these two equations and two variables, we are going to solve them at the same time. That is why we say that you are solving them simultaneously. In the same way, we have two equations and two variables here. We are going to solve the two equations at the same time. So we say that you are solving the two equations simultaneously. So it can be seen clearly from here that the number of variables in the equation determines the number of equations you need in order to find the variables. This is what I mean. Here, you have only one variable, so you need just one equation to solve it. In the same way, here you have only one variable, which is a, so you need just one equation. So with this equation, we can find a. But when you come here, there are two variables, a and b. So you need this equation and another equation so that you can find a and b. In the same way, when you come here, there are two variables, x and y. So you need two equations to solve them. Now, as soon as we have two equations, we say that we are going to solve the two equations at the same time. So we are solving them simultaneously. Let's look at this example. We have this equation, x plus 2y minus z is equal to 2. Now you can see from here that we have three variables, x, y, and z. So in order to find x, y, and z, you are going to need three equations. So you need an equation like maybe 2x plus y plus z is equal to 7 and x minus y minus z is equal to 11. With these three equations, you will solve them at the same time in order to find x, y, and z. So the number of variables in the equation determines the number of equations you need to find the variables in there. In this video, we are going to concern ourselves with simultaneous equations in two variables. So we are going to consider these types. We will not be considering the one with three variables or more. We will just concern ourselves with two variables. I hope this is clear. Now, we are going to learn how to use these methods to solve simultaneous equations in two variables. So we will be considering the elimination method, the substitution method, and the graphical method. Thank you for watching this video on Introduction to Simultaneous Equations in Two Variables. See you in the next video where we will learn how to use the first method, which is the elimination method, to solve simultaneous equations in two variables. Bye-bye.